Good afternoon, my friends, my viewers at home. Uh, Today, we're going to be working on a very interesting video that borders around electrode potential and its calculation, which is what will be my interest, and it will be in our next video. But for this first video, we want to talk about strictly on the like a preamble on what we call an electro potential and the things we need to know so that when we get to the calculation aspect of this this part, it will be easier for us to solve and analyze them. Please, if you have not subscribed to my YouTube channel, do your best to just click on the subscribe button, like and comment. And for any question you will have, feel free to drop it on the comment section. Then I will give you reply as soon as I get them. Now, today we work on what we call the electrode potential. Now, what is an electrode potential? An electrode potential is the potential difference that is what now that is set up between a melter and a solution of its ion of salt. So that's some basic terms that you should come to understand that will guide you in the next step. Now, and the symbol for electrode potential is E. That's the symbol, while its unit is in volts. And now we move straight into what we call a standard electrode potential. Now, the standard electrode potential of a melter ion slash smelter system is the what now? Is the potential difference set up between the melter and a molar solution of the salt at what now? At room temperature, which is at 25 degrees Celsius or 298 Kelvin. Is that clear? Now we move straight away to what we call to this term here. Now, it will be noted that generally the standard electrode potential, you see the symbol right now. For electrode potential, we use the symbol E, but for standard electrode potential, we basically make it what we call the E naught, whereby this naught stands for the standard condition. You get me now? I said of any system is always as a reduction process. It will help you in our next video that we will do. So you should know how the questions always come. That in the case of that for all standard electric potential, it comes in this format, as you can see right here on the board, whereby from +2 to 0 is a reduction process, and you have it here. Here too, the same. So it means that all that generally the standard electric potential of any water system is always in its reduction process. Don't forget that oxidation reduction in terms of oxidation number can be defined as oxidation is an increase in oxidation number, while reduction is a decrease in what now? In the oxidation number. They move strictly to what we call the inner. Now, don't forget that the standard electrode potential can be used to what to determine whether a substance is acting as an oxidant or as a redundant. But don't also forget that the other name of an oxidant simply means what now can also be called an oxidizing agent. So I can come here and say, oh, hey, while a redundant is also known as a reducing what now agent. Don't forget that for any species to act as an oxidant, that species must be undergoing what we call what now reduction, a loss of electron. That clear now? Why redundant? Any species that should undergo that should be called a reducing agent is undergoing oxidation process. Is that clear? Now, if you have understood the fact that standard electrode potential is used to determine whether a substance will be called an oxidant or a reductant. Now, what are the three major cases that we are to encounter in such in such contact? Now, there are three cases basically under this forum, and we have what we call the case one. We can also have what we call case two and Lastly, case 3. Now, for case 1, what should we understand here? There are cases whereby the standard electrical potential of two substances or two systems, let's say A and B, both are what now? Both can be like I mean, A can be positive, which is let's for example let's say 0.34 plus 0.34 volt, and B can be negative, let's say minus 0.80 volt. Now, when I'm having two systems in which A is positive, which is the electron potential standard, and B is negative, take note that the more negative here will be acting as the reductant, as the reductant, while the more positive will be acting as the all-vidant. It's a rule. So, for example, if I'm having something like, let's say, I'm having plus 3.05 volt, I'm having minus 0.24 volt. Just note that this one is the what is the evident, why this one is what now the reductant. I move to case 2. Case 2, I can be having both to be negative. Let's say, for example, I'm having A again, I'm having B, two substances. A is minus, let's say minus 0.40 volt, and B is minus 0.80 volt. When the two species are negative, take note, the more negative will be the reductant. So here becomes what now? Reductant, while the less negative becomes the what now? The evident. Because the truth is, your understanding of this basic term I am illustrating for you right here on the board will help you in so many areas. Don't forget that electron potential, which falls under what we call an electrolytic cell, falls under what we call like it's a branch of physical chemistry, which is basically calculations and some terms which will help you. Now later videos are helpful. Now in case 3, whereby I'm having A and B and both are positive, let's say I'm having plus 0.64 volt and B is plus 0.90 volt. Look at it. The more positive will be the evident, and the less positive will be the reductant. It is as easy as that. Very, very easy. You get me now? That is how easy it is. So we'll move to the next case. All right. So we continue. Now, what we call a cell notation. In all our calculation that we will do in electron potential, we should know what we call a cell notation. Now, a cell notation is a shorthand way. Look at it. It's a shorthand way of representing a cell. I repeat, a cell notation is a shorthand way of representing a cell, just like what you can see here. Now, there are rules that are followed, or steps that you must follow to understand what we call like a true way of representing a cell. And the steps are: 1, that the oxidation half cell reaction is written first, or it's always at the left hand side, as you can see here. You get me now? And number 2 is that the reduction half cell is now written on the right hand side. And number 3 is what we call a sub bridge. A sub bridge is what separates the oxidation reduction half reaction, and we use this is the sign we use to represent it, just like what you can see here. At the same time too, we will now understand each of these reduction half reaction and oxidation half reaction and reduction half reaction. Now, how the species are connected. Take note. There's what we call, like, sometimes when you see where they use just a single slash, it represents interface. Interface, especially when the the component of the oxidation half reaction are not of the same state. For example, if I'm having copper and I'm having copper 2 anion like this one is solid, this one is aqueous, and I'm to represent it in an half, like oxidation half reaction. Simple. I'm just coming to say Cu, see, then Cu 2 plus, as you can see, as Cu and Cu 2 plus. Why? Because they are not of the same state. But if they are of the same state, let's say gaseous, let's say A and B are in gaseous, then simple, we use a comma to represent it. That is how easy it is. That this is a salt bridge. Now the question now is, what is the function of a salt bridge? Simple. A salt bridge, what now, maintains electrical neutrality, what now, within the internal circuit, and also provide what now, it also provide a means of support that connect the free flow of electrons, or sorry, the free flow of ions from the oxidation half cell to the reduction half cell, like something like this. Like I'm having something of this nature, let's say something like this part here, this part, and then I'm having what you are seeing here in particular. This is what we call the salt bridge. I'm just giving you a sketchwork. Just giving you a sketchwork. Whereby this part is for the oxidation, this part is for what now? The reduction. And in our next video, we'll take our time to solve questions on on how it is, and also next equation. So please, if you have not subscribed to our YouTube channel, do well to subscribe. I still remain Abdullah the Bazooka Prophet. I love you guys. God bless you.